Okay, in section 5.2, we're going to talk about a new kind of probability distribution, which is called a binomial distribution. And it results from a procedure that has to meet these four criteria. First one is that it's a fixed number of trials. That is going to be our n. The trials are independent, meaning that the outcome of one trial doesn't affect the probabilities for other trials. And each trial has an outcome of one of two categories. Success or failure is what we usually refer that to. It's usually a yes or a no. You are male or female, or whatever it might be. It's only two options: yes or no. And the fourth item is the probability of success remains the same in all the trials. And so you have some population information, and that's what derives that probability of success that we're going to use. Some notation here. I just want to go over that again. X counts the number of successful trials in n trials. So X is what you're seeking out of a total number of n trials. And it can be anywhere. That X can be any value between 0 and n. And again, these are going to be countable numbers: 1, 2, 3, 4, 5. The probability of success is going to be identified as P in our formula, and the probability for failure is going to be identified as Q in our formula. And those two are going to be complements of each other because they make up the entire sample space. Okay, so you're going to be using this formula when we're calculating probabilities, and you're going to need to demonstrate that you know how to use this formula on a test. So I want to make sure that we're good with this, but I'm hoping that you recognize that this could be this first part that I put in a circle is actually from section 4.4, and it's our formula for combinations. So you would actually use this kind of notation here. As long as you have a scientific calculator, you can calculate the combinations there. And then our probability raised to a power, and then our probability of failure raised to the complement power. So you're going to notice that these two things are complements. In other words, they make up the total n space. A lot of different formulas and notation going on here. So I think the best way to really wrap our head around it is to actually do a problem. So your goal is you're trying to use the formula to find the probability of getting a certain number of successes out of so many trials. Okay, when an adult is randomly selected with replacement, there is an 85% probability that this person knows what Twitter is, based on the results from the Pew Research Center. By the way, Pew Research Center is a very reputable research center, and so you're going to find a lot of research from them. Suppose we want to find the probability that exactly 3 of 5 randomly selected adults know what Twitter is. First thing that we need to do is, does this represent a binomial distribution? And that might be a question that is asked in your very initial my stat lab questions. And what you need to go back up here is check to make sure that these 4 criteria. Is it a fixed number of trials? Yes, we're going to be looking at out of 5 in a group of 5 adults. There's 5 trials. Are the trials independent? Yes. What one individual knows about Twitter, the other knows. It doesn't impact any of the others. Each trial has the outcomes of success or failure. So success, they do know what Twitter is. Failure, they don't. The probability of success remains the same for all trials. So this probability of 85% exists for all 5 of the adults. Okay, so that does meet the criteria. Identify the values. N is 5, X is 3, our P is 0.85, and our Q is 0.15. Okay, find the probability that when 5 adults are randomly selected, exactly 3 of them know what Twitter is. You're going to round your answers to 3 significant digits. This is the formula up here that you're going to be using. So you need to plug that in. So the probability of getting 3, the probability of 3 is equal to 5 combinations 3. 3 of them are going to have this success. You're speculating that 3 will have the success of 85%, and the other 2 will have the success for failure, 0.15. So you would generally plug this in your you need to plug this first part into the calculator. I'm hoping I can show you that. I just want to remind you from chapter 4.4, we use this. Just keep in mind, again, that you have to put the 5 in first. So I'm going to put in 5. Oops, I need to turn this on. 5, and then I'm going to go to probability. I need to go down to combinations, select that, and I'm going to put in the 3. So what I'm telling the calculator is in a group of 5, how many combinations will have 3 of success? Well, how many combinations of 3 can we come up with? And that gives us 10. So that's how we got that part. Now again, this 85 to the 3rd power, you could do that in your calculator. And then the 0.15, do that in the calculator. So you have 3 different components that you need to put in the calculator, list them, and then multiply those together. So we come up with 0.138. Okay, the way you interpret that is there is a probability of 0.138 or 13.8% that exactly 3 of 5 adults know what Twitter is. Now we can do this in StatCrunch. So I need to open that up. So when you go into StatCrunch, we're going to be using a new calculator. So I'm going to go to Stats, Calculators, and I want you to recognize again that when you're using calculators, calculators will help you identify probabilities. So I'm going to go to the Binomial calculator. It will default to this screen here, and it's prompting you to put in the information. We had n was 5. Our probability of success is 0.85. It's going to calculate the Q in the background. You don't have to worry about that. Down here, I'm looking for what is the probability of getting 3 successful. So I'm putting in that random variable 3. Now, for my sign here, my question was exactly 3. So I go down here and I have to click the equal. And so it's going to provide our histogram here. And it's going to tell us, again, that the probability of getting exactly 3 adults comes out to be 0.138 onward. We rounded it to 0.138, 3 significant digits. Now I want to point out that you can use the StatCrunch to find a range of outcomes. Let's say I wanted to know what is the probability of getting less than or equal to 3. In other words, 0, 1, 2, 3 adults. That comes out to be 0.16. That would round to 5, so 0.165. What if I wanted to know, and notice that it highlighted in red the 3 bars that it's taking into account. If I wanted to know greater than 3, so now it's highlighting the last 3 bars, and that's a large majority, 0.97 and 3% probability would have 3 or greater. So StatCrunch is pretty sweet because it allows you to use these inequalities to find a range of outcomes. Okay, so you can use this as you work through, but I definitely want you to watch the next video about where we really outline a couple different things.